A metal block of density 6000 kg per meter cube and mass 1.2 kg is suspended through a spring of a spring constant 200 Newton per meter. The spring block system is dipped in water and kept in a vessel. If the water has a mass of 260 grams and the block it is at a height of 40 centimeter above the bottom of the vessel. If the support of the spring is broken, calculate the rise in temperature of the water. Alright, now let's say this is my system. There is a spring, a block is attached to it, system is dipped in a water, okay, and this height is given as 40 centimeter. So again, the change in the energy of the system is equals to rise in the thermal energy of the system. Fine, so this is the concept. I'll write the initial energy of the system first of all. The initial energy is first of all the spring energy plus the potential energy of the block. Now at initial the equilibrium is maintained, so mg is equals to kx plus v rho g. Alright, now this mg is the total weight of the block that is acting downward. Kx, that is the spring force, will act upward, where k is the spring constant, x is the elongation. Alright, and this is equals to v rho g, that is the volume of the block, and rho is the density of the water, and g. Fine, so volume of block is mass divided by density. Alright, substituting all the values over here, I get the value of x as mg minus m rho of water by rho of block into g divided by k. So elongation comes out to be 0.05 meter. Alright, I have the value of x now. So the spring energy is given by half kx square plus potential energy of the block, that is m, into g into h, that is 0.4. So substituting the value, I have half of 200 into 0.05 whole square plus 1.2 into 9.8 into 0.4. So the initial energy comes out to be 4.954 joules, and the final energy will be equal to 0 because block will come to the ground, so h will be 0, and spring also cut down, so extension is 0. Now this energy 4.94 minus final energy, that is 0, will be totally converted into thermal energy. So 4.954 is equals to the thermal energy, that is equals to mc delta t, that is for block, plus mc delta t, that is for water. Alright, now mass of block is given as 1.2, specific heat of block is 250. Let's say the final temperature is delta T plus mass of water, that is 0.26 into 4200 into delta T is equals to 4.954. Solving this equation for delta T, I get the value of delta T as 0.003 degrees Celsius. That is the answer.